It is nice to have you with me today on NASENI Milestones, where we talk science, technology, and innovation with a view to understanding efforts by the National Agency for Science and Engineering Infrastructure, NASENI, at instituting homegrown technology in Nigeria. Technology can be classified into two broad categories, namely material technology and knowledge-based technology. Today we are focusing on material technology, where knowledge is embedded into nanotechnology products such as tools, equipment, chemicals, polymer, and ceramics. And in order to make you appreciate better this concept of technology and capacities of Nigerians in this area, we go to the NASENI Center for Excellence in Nanotechnology and Advanced Materials in Akure. By the way, nanotechnology and advanced materials are fields that are vast and extreme in depth, and it is a fertile arena for research, education, economic development, and entrepreneurial impact that spans the science, engineering, and is rapidly going into medicine and agriculture. The NASENI Center for Excellence in Nanotechnology and Advanced Materials is often, described as an organizational environment that succeeded in developing standards of conduct in the field of research, innovation, and learning. Let's go there. At NASENI Center of Excellence in Nanotechnology and Advanced Materials, there are various laboratory equipment used in carrying out complex tests. First is the XRD equipment for sample analysis to determine the structural property of any material. Here is Adeyemi Lumide for details of that and more.
Just like we know, every material is made up of atoms and the way they are arranged. So that gives us the better understanding of how the crystal arrangement, which is also the crystallographic study of our sample. This equipment is very, very important in our material analysis to give us a fair knowledge and a better understanding of what our material is made up of. Today, I will take us through on how the processes of how the equipment is being operated. Here we have the chiller. Now, once the chiller is on like that, we set up our parameters. I on the X-ray. When the X-ray is on, the X-ray light came on. So I on the X-ray. Then I come to the system, I set up the required parameters. At what angle I want the equipment to start, and at what angle I want it to stop. I set up the whole parameter. Then I go to where I prepare my sample. I prepare my sample. This is a sample holder. Everything we do here, it has to be clean of impurities. We clean our machine and all the materials that we use so that we don't have any impurities in our sample. Because the machine is very, very sensitive. It might pick up impurities at the end of, during our analysis. So it is important we try as much as possible to minimize it. This is a client sample I'm about to analyze, a geological sample from the client I'm about to analyze. I'll put them in the sample holder. After this is done, I would compress it inside the cavity of the sample holder. All this I'm doing is very, very important so that we can have a better and a good result at the end of the day. So once this is done, I take it to the machine. Stage of the sample holder, where the sample holder is. Just like I said, this is the source of the X-ray generation. So the X-ray is being generated from here, it shines on the sample holder, and this is the gonometer that picks the radiation at different points so that we have the peaks on the system. So we shot the sample. Then I come back to the system, I set up the parameters, the sample name, just like as the client represent it. The client calls this sample A. So after we input all this analysis, we start with the equipment. If you look at it, the estimated time for the equipment to run is for 30 minutes. So once all these parameters are met, the X-ray will start on its own. It's an automated system. Just like I said, this is an aluminium sample. Just look at the matches, the peaks. They are aligned with what the machine done. That shows that the material is a pure aluminium sample. So from here, we copy it and give it to the client, which shows that the work has been successfully done.
Taufid Ahmed here explains the thin film thickness measurement equipment, an instrument for measuring the thickness of thin film materials at the nanometer level. There is also scanning probe microscope for imaging and to view specimen from nanometer level using delicate probes instead of light waves of electrons. It is applied for characterizing and fabricating nanostructures on surfaces.
From the name, it's a microscope, and what does microscope does? They help us to magnify our view of objects or materials so that we can have a clear picture of what the material is and understand it. Imagine today we are talking of nanomaterials. So, and you want to have a very clear view of material. For instance, I have this film of gold on a glass surface here. So I have this thin film of gold on this very about 0.5 centimeter square glass substrate, and you can see that the only thing you can see here is just a flat surface. So, and this material has a topography and has a structure on the surface, but you cannot be able to see this with our own naked eyes. So we need an equipment such as this microscope to be able to view structures and devices like this, so that we can be able to understand them, see whether they have the proper properties that we want them to have. You'll be surprised to see that what you are looking at, look at the, I'll show you the, okay, so look at this. So this is like the 2D dimension, to the 2D view of the surface. You can see we have some blackish line, we have some whitish line. So the blackish line has thickness, the height on the material is about 0 nanometer. And so as you go up, this is the scale. This is from 0 nanometer to about 87.2700 nanometer. So you're actually doing your measurement on a scale of nanometer on this equipment, and that is telling you that your research is actually nanotechnology based, because in nanotechnology you are taking measurement of materials in order of nanometer. That is 1 billionth of a meter. That is when you divide 1 meter into 1 billion, then that is a nanometer for you. And so you can see, so this is what we have here. So you can see this is the scale, and then you are not able to even appreciate this. But if you see there is the 3D view, you can be able to appreciate this better. Yeah, look at this. This is wonderful. So this is the 3D view of the surface that we are looking at. The whitish region, you can see, they have more depth. Look at the scale. This is all the whitish layer. They have their height on the surface is 87.27 nanometer. And then the lower level, the one that look like valley in between them, that is 0. That is, you have 0, and then you have this. So you have, it's telling you that you have some line that has height of 87.27, and you have some drop. So you can take the one at the lower end as what do you call, as a negatively conducting end, that is as the cathode, and then you have the positively conducting end as the anode. And so you can take your, so you can have this one is telling you that you have, basically we are seeing two cells here. This is one positively layer, this is one negatively layer, and then that's a layer. This is another positively layer, this is another negatively layer. So from this you already have like two cells here. So this is just like a few of the microscope. Then you have a wide range of it. And so this can be combined, and then we can be able to easily, for instance, if we use this in solar cell, so we are able to, create an effective solar cell that can be arranged to form a solar panel that we cannot, because actually a solar panel is billions of solar cells. Billions of solar cells regularly arranged in a regularly repeated manner.
Nano Indenter is a sensitive machine for measuring mechanical properties of small volumes of materials using an instrumented indentations techniques. We learn more of that.
A nano indenter essentially is an equipment that is used to carry out physical property of materials using indentation system. So, and basically what it does is that, so you have this indentation system here, which has, this is the indenter, and this is the sample mount through which you can mount a sample and place it. And this is where the force that the indenter is using to create indentation of the sample. This is where it's generated from. And then the feedback and everything goes back to the computer system that we use to operate the equipment. So basically, you have other equipment or other ways of carrying out physical property of materials. Physical property include the hardness of the material, the toughness of the material, then the brittleness of the material, and also you need to know tensile properties. You need to know the breaking point of a material. So all these are very important properties of materials that you need to check for any kind of material that is being used in engineering processes and machineries. So for instance, typically you can use like non-ferrous metal, ferrous metal, polymer material, ceramic material, and a lot more kind of materials. So, and typically, maybe you want to work on, you want to build like a system that you can use in maybe building construction, like metal rods. And we are talking about how building and collapsing, where you buy a gauge of metal, expecting that it has some important property that can be able to withstand the load on the building. But because those materials just buy it off market and just apply it, no, it's wrong. So what should have been done is after they have purchased the material, they should bring the material to such a place like this, such that the proper properties can be properly analyzed and then ascertain that this material has the kind of hardness, toughness they should have, so that when they are used in building construction, that will not be building collapse.
Scanning electron microscope laboratory is where there is an equipment that uses beam of electrons to scan materials to form an image. Here is Jide Kazim Bidemi.
So the first thing we do here is to switch on the machine, switch on the system, then you vent the system. After venting it, you wait for some minutes for it. Okay, then you open the sample chamber. This is our sample we intend to coat. Okay, there is yam flour on it on the sample slide. Then you put it here with a masking tape. Then you cover the sample chamber that is in a vacuum, so it works under a vacuum condition. This is that the machine utilizes an electron, what's it called, an electric field and argon gas. In terms of electric field, electrons are removed from the argon gas, making it positively charged. Then this positively charged argon becomes attracted to the gold foil inside the system, thereby ejecting, removing an atom from the gold foil. Thereby, the gold atom will fall on the sample, and it will coat the surface of the sample with a thin gold. After that, we come to this side. This is our magnifying lens, and this is our filament. We open this using this under the magnifying lens, and we set the filament at the center. The filament, why we do this and why it is important to set it at the center is because the filament is what we put in the sample, and it's the one that generates electron. From there, we bring it here, open this, insert this. Then after that, we can now start the operation. In the system, electrons are generated at the top of the microscope, and it follows a vertical path in the microscope, held within a vacuum system. After that, the electron travels through electromagnetic field and lenses, and it is this field and lenses that focus the electron down towards the sample. Once the electron hits the samples, electrons from the samples are ejected. There is a detector within the system. These detectors collect extras, secondary electrons, and backscattered electrons generated from the samples, and these are converted into the signal. The signal will be sent to this, and it will be captured in form of an image. And here are the examples of what we've done so far. These are taken at different magnification. This is 200 magnification, we have 500, we have 180, we have 100, and we have 5,000.
The next equipment is the vibrating sample magnetometer. I'm told it's the only such type in West Africa. It's used in carrying magnetic properties of materials.
Typically, any material has three basic properties. You can look out for the physical properties, you can look out for the electrical properties, you can look out for the magnetic properties. So there are some other properties, but at least these basic ones are the basic ones that any laboratory whatsoever should have a means of testing. So here, for our magnetic properties, we use the vibrating sample magnetometer. And so basically, we have, the equipment has like 3 or 4 phases. We have the chiller here, which is used to cool the electromagnet when it gets hot during operation. And then we have the electromagnet here, which produces the magnetic field that we need to analyze the material. And we also have the control system, which produces appropriate power and voltages to the different components that we have, including the electromagnet, the vibrator, and the magnetic moment sensor that we have there. So we also have the computer system, which is used to control everything, because everything about the equipment is automated. A user just needs to prepare the sample, do the calibration, and then run the test. We have a digital oscilloscope, which we use to study electrical signals, input and output electrical signals from a device. So we also have a Ketley 2400 source meter, which essentially produces power for any component or device that we want to test. So from the name source meter, you can use it to source voltage and measure current. You can use it to source current and measure voltage.
Well, there's no doubt that the NASENI Center for Excellence in Nanotechnology and Advanced Materials houses some of the best equipment in nanotechnology and advanced materials in Africa, ranging from preparatory equipment to that of characterization and equipment for analysis relative to the application of materials. The various equipment types cut across all areas of nanotechnology, such as nanomedicine for disease detection and treatment, nanoenergy for solar cells and light-emitting diodes, nanobiology in agriculture for production of drought-resistant seeds, foods preservation and genomics, plus nanoporous materials, that is production of nanoporous filters for water purification and biooxidants. The most interesting is the amazing capacities and skills of Nigerians at the center. These are scientists and technologists who are championing the cause of homegrown technology in Nigeria. Up ahead, we get to hear from the Executive Vice Chairman of NASENI, Engineer Professor Mohammed Sani Haruna.
NASENI has a center of excellence in nanotechnology and advanced materials. This center of excellence is unique, has state-of-the-art equipment that is first of its kind in this region. The center's operation is to develop new materials, composite materials, to experiment combination of materials, to develop new materials, and to see if you have succeeded in producing any materials, the facilities there will be able to characterize it, to tell you the composition of the materials, the percentage of each item. The processes of developing products in engineering require that you optimize, you add or reduce certain features. If you want, for example, more ductility, or you want more elasticity in any product you are producing, you need to know the degree of it in each of the materials you are having. And what will you add? What will you reduce in order to give you that? So we have equipment that characterize, analyze, and give detail. Again, if a material is discovered and we don't know what it is, for example, we want to reverse engineer something, we don't know. This is made of some composite materials. To characterize it, to analyze it, to know exactly what is its content, what is it made of, and what percentage of each item is in it, in the nature of the materials. It is in this center of excellence that we have every equipment that is needed in order to characterize, to combine, to develop, to reinvent a materials. Because particularly is serving us so much in what we call additive manufacturing. In our additive manufacturing, we need to use our element that is locally available to mix our own materials to give us what we need. Now, in order to avoid hundreds trial and error processes, you just go to our library of materials. It gives you percentage of what you are looking for. For example, I want elasticity. Before I start doing trial and error, my library, my material library, will tell me this materials and this material so percentage will give you so degree of elasticity. Therefore, in my first attempt or first product, I will come close, if not exactly, to the elasticity I mean, based on the availability of materials we have in nanotechnology. And the center, because of it's very expensive, it was with the help of World Bank funding that NASENI bidded and won to support us in bringing these materials. One interesting thing about this center, some of the equipment that are there are never produced elsewhere in the world. NASENI specified that we need machine that can do this, can do that, can do that. When we couldn't find, we have consortium of manufacturers of scientific equipment that work together to produce certain equipment for us that you see in this center.
Here, we have a common mandate to make available to the country critical skill personnel and products in areas of nanotechnology and advanced materials. This our core mandate cuts across the 4 critical needs of this country. The 4 critical needs of this country that our mandate covers are the nanomedicine, the nanofiber engineered materials, nano energy, and then nano agriculture. So among these 4 broad areas, like when we talk of nanomedicine here, we are looking at the areas of nanomedicine in one that will help us to fight some deadly diseases like cancer through developing the method we call target drug delivery system. So in nano agric, we are talking of developing drug-resistant seeds, nano fertilizer that will help the country improve in the agricultural sector. Then, we are tapping on this all important technology.
And that's our show for today. We thank you for being part of it. Do join us again next week for a fresh package of NASENI Milestones. Be part of Homegrown Technology Initiative. I am Kirian Umayo. It's bye for now.